Hello. Today, the focus of the video is going to be the first two types of transformations that we have. We're going to talk about translations and reflections. So these two at the top. We're going to review what we've already learned about translations, and then we'll expand into reflections over the x-axis. Remember, we need to be able to identify what those transformations are and also apply them to point, tables, graphs, the whole works. So just as a quick recall, these values, when you add or subtract to the inside, this is going to give me a horizontal translation. And when I add or subtract to the outside of my function, that is going to give me the vertical translation. Okay, so we have to know, okay, if I'm adding or subtracting a value, we have to look at where that is located. Is it inside my quadratic, the squared piece, or is it outside? And that's going to tell me what direction I'm moving. So I have an example here. If I have x plus 7 squared, now because the 7 is being added on the inside, we know that that's going to be a horizontal translation. And remember, when it's on the inside, we are going to use the opposite. So it's going to actually go to the left 7 units. Okay. So again, it was a horizontal translation because it was inside the parentheses. And then it was left because anytime you add something inside the parentheses, it will always shift left that number of units. We got another one here. Okay. So here, if I were to subtract 13 on the inside, I'm still going to be that horizontal translation, but it's now going to go to the right 13 units, right? So if you subtract on the inside, the intuition tells me it probably goes left because I'm subtracting, but remember, when it's inside the parentheses, we always need to use the inverse. We want to go to the inverse direction, so it's going to be to the right 13 units. Okay. Now, if you take a look at this one, this is the one that some people make mistakes on. The reason being is because they see this subtracting 5, but if you notice, it's no longer inside the squared piece. It's no longer with the argument. It's at the end of my quadratic, if you will. So when you subtract 5 from the end, that is now going to be a vertical translation, and that's going to go down 5. We don't take the opposite of anything. If you subtract to the end, it goes down. If you add to the end, it goes up. Okay, so this would be a vertical translation down 5. All right, so let's put some pieces together here. I have both types of transformations in this problem. So the first one, you can see I'm adding 2 to the inside, which means I'm going to have a horizontal translation left 2. Okay, remember, if you add on the inside, it's going to go to the left 2. Now this 16 is being added to the end, which means I'm going to have a vertical translation up 16. Okay, so those would be my two transformations. I think I got one more of these. Oh, we're going to do it to a table of values now. Okay, so first, let's figure out what are the transformations that were taking place from our basic quadratic to f of x, right? So I know there's going to be a horizontal translation right 3, and I'm also going to have a vertical translation down 5. Okay, so the minus 5 shifts my graph down, and then the minus 3 on the inside shifts my graph to the right 3. All right, so now let's complete this table of values. If I want to move my graph, let's start with the horizontal translation. If I want to move my graph to the right 3, what I want to do is I want to take all of my x values and I want to add 3 to them. Okay. If you add 3, it's just going to shift over to the right-hand side. So I'm going to take this -2 and I'm going to add 3. -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Okay, so I get my new x values. Now to move my graph down 5, well, that means I'm going to change my y values. That kind of makes sense. I'm going to subtract 5 from all of my y values, right? So you're going to take all of your y values and you're going to lower them by 5. So 4 minus 5 is a -1. 1 minus 5 is a -4. 0 minus 5 is a -5. 1 minus 5 is a -4. And 4 minus 5 is a -1 again. So now I know what the basic function looks like. The basic function, goes through that origin. All right, but let's see what this new function looks like after the transformation. So I'm going to plot these points. I'm going to say, okay, I'm going to go to 1, -1. Then I'm going to go to 2, -4. There we go. And I'm going to go to 3, -5. 4, -4. And 5, -1. So what I get is I get a graph that has been moved not only to the right 3 units, but it's also been moved down 5 units. So you can see it's actually been shifted. Okay, let's do it again. Practice makes perfect. So let's first identify the transformations, right? Going from one to the other. So I'm going to have a horizontal translation left 6. Then I'm going to have a vertical translation up 2. Again, the +2 at the end is my vertical translation, and then the +6 is going to move my graph left 6 units. So let's start with the horizontal translation. I'm going to take all of my x values and I want to move them left 6, so I'm going to subtract 6 from all of them. Likewise, I'm going to take all my y values one by one, and I want to move them up 2, so I'm going to add 2 to all of them. Okay, so -2 minus 6 is now a -8. -1 minus 6 is now a -7. 0 minus 6 is a -6. 1 minus 6 is a -5. And 2 minus 6 is a -4. Now to move my graph up, I'm going to add 2 to all the y values. 4 plus 2 is 6. 1 plus 2 is 3. 0 plus 2 is 2. 1 plus 2 is 3. And 4 plus 2 is 6. So now I can just plot these points. -8, 6, -7, 3, -6, 2, -5, 3, and -4, 6. So here is my new quadratic. Now, if you compare that to the original, we know the original is at the origin here, okay, with the vertex at the origin. You can see that I just shifted it left 6 units and up 2 units, okay? All right, practice makes perfect. Okay, feel free to pause. Try to do this one on your own. See what you get. Okay, so if you want to do it on your own and you don't want to hear me talk, pause it. So I'm going to have a horizontal translation right 4. I'm also going to have a vertical translation down 3. So what's going to happen here is I am going to take all my x values and I want to go to the right 4. So I'm going to add 4 to each of these x values. Okay, so that would give me a 2, a 3, a 4, a 5, a 6. And then if I want to go down 3, then I'm going to subtract 3 from all of the y values. So 4 minus 3 is 1. 1 minus 3 is a negative 2. 0 minus 3 is a negative 3. Negative 2 and 1. So now I can just plot those points to 1, 3, negative 2, 4, negative 3, 5, negative 2, and 6, 1. And that gives me my quadratic. Okay? So let's talk about these reflections, right? How can I identify a reflection? How can I apply it? You know, that's kind of the idea, right? So the reflections that we're going to talk about today come from this a value, come from in front. And when this is negative, there's going to be a reflection over the x-axis. Okay, so when you have a negative value in front of your quadratic, it's going to take my graph and it's going to make it concave down. Well, that's a reflection. That motion going from concave up to concave down is a reflection. Well, let me refresh my slide here. There we go. Okay, so if you compare these graphs, right? So I have the basic, the original, if you will, is just normal. Okay, but when I put a negative out front, it takes that graph and it reflects it over the x-axis. So it's kind of like I'm going to take my piece of paper and I'm going to fold it over on the x-axis, and that's going to give me a new graph, and that graph will be concave down, right? So whenever you have that negative out front, we get this added transformation. We get this reflection. So if you take a look at these, trying to put all the pieces together. So you can see this negative out front, right? This is going to be a reflection over the x-axis. Then I have the minus 9. That is going to be the horizontal translation, right 9. And then last but not least, I have the plus 4. So that would be a vertical translation, up 4, right? So you have 3 transformations in that one. Now, if you take a look at the second one, now if you notice, I have a negative here. That's going to be my reflection over the x-axis. So that's what makes it concave down. And then we have this minus 22 at the end. So that all that's going to do is going to be a vertical translation down 22. Oh, I forgot to write my 4 in the first one. All right. So we need to identify, notice I just keep building. I keep adding more transformations into these problems, right? So here's another one you can do on your own. Feel free to pause. I'm going to write the answer up here. So the negative is a reflection over the x-axis. Then I have the plus 1, which is a horizontal translation, left 1. And then last but not least, I have a minus 13, which would be a vertical translation down 13. Okay. All right. I'm going to skip ahead to the tables. All right. Now, when you have a reflection, when you have this negative, what we're going to do is we're going to take and we are going to multiply all of the y values by a -1. So we want to multiply all of those values. When we have a negative out front, we're going to take the y values and multiply by 1. So the x values stay the same. Those don't change. -1, 0, 1, 2, right? Those don't change at all. But what I am going to do is I want to flip them down to the bottom. And to do that, and multiply all the y values. So 4 times a -1 gives me a -4. 1 times a -1 gives me a -1. 0 times a -1 gives me 0. So on and so forth, right? So I get a -1 and a -4. So now I can plot those points. -1, 0. And it gives me the quadratic that is upside down. So again, when we have this negative, we are going to multiply all y values by a -1. Okay, so we're going to do some further problems in class, but I want to see whenever you have that, we always want to multiply the y values by a negative. Okay, all right, hope this helped.